So, what we're going to be talking about today is the logarithmic function, and this is our last function that we're actually going to learn this year. And the reason we do exponentials and logs together is that the logarithm is the inverse of the exponential function. Excuse me. It undoes the exponential function. The problem with solving an exponential equation is that x is in the exponent. So how do we get rid of that base? How do we undo that base? And so the logarithm was designed to be the opposite of an exponential. It's the opposite of a base. When you are dealing with a logarithm, you are looking for an exponent. So how can you think about a logarithm? So let's talk about that for a second. The way we write logarithms is we do use the abbreviation log. And so when you see the word log, that is talking about a logarithm. And if I have something like log base 3 of 9 equals, how do I evaluate that? What you have to realize is that a log is basically asking you for an exponent. So this is the log. This right here we still call the base. It is the base of the log. And it is the base of the exponent we're looking for. And so when I read log base 3, that's how I would read that, log base 3. Log base 3 of 9, it's asking me for the exponent of 3. 3 to what power equals 9? 3 to what power equals 9 is the question that's being asked of me right here. So when I'm asking for a log, I'm asking for an exponent. So 3 to what power equals 9? Well, 9 is 3 squared. So that would be equal to 2. The answer is itself the exponent. You are looking for the exponent. So 3 to the second power is equal to 9. And that's what we're looking for. So when it asks you to evaluate a log, that's what it's saying. So if I have log base 2 of 16, that question is asking me 2 to what power is equal to 16? Well, 2 squared is 4, 2 cubed is 8, cubed to the 4th is equal to 16. So 2 to the 4th power is equal to 16. So 2 was the base, 4 was the exponent. It was equal to 16. That's what a log is asking for. This works for all types of exponents. I could have log base 4 of 1/16. I'm like, whoa, wait a minute. 4 to what power equals 1/16? How am I supposed to figure that out? Well, 16 is the power of 4. If I do 4 squared, I get 16. But this isn't 16, it's 1 over 16. 16 ended up in the denominator. Well, what exponent makes us put things in the denominator? Oh, a negative exponent. So if I did 4 to the negative 2 power, that would be equal to 1 over 16. So you can have negative exponents. We've learned this year too that you can also have fraction exponents. If I have log base 25 of 5, 25 to what power equals 5? Well, the square root of 25 is 5. Well, square roots. How can we do square roots as exponents? Oh, taking something to the 1/2 power is the same thing as a square root. So 25 to the 1/2 power would be equal to 5. So these exponents can be equal to just about anything. So we're looking for the exponent. 25 to what power is going to give me 5? This is what we're looking for here. Now, of course, we do live in the technology age, so thankfully we do have calculators that can help us do this. But we need to look at something real quick on your calculator. On your calculator, there are actually a couple of buttons that go along with logarithms. So let's take a look at those particular buttons. If I have a TI 80 something calculator, these are the two buttons that are logs. We have LOG and LN. And these are just two specific logs. You do need to be aware that this is not just any log. This LOG with no number, notice there's no base there. Okay, there's not a base. All these problems over here, there was a number written there. Those were the base. This one does not have a base. Whenever you see the word log and there is no base, this is what we call the common log. Again, it's just the one that we use the most often. And the common log is a base of 10. It is a base 10 log. So whenever you see the word log and they give you no base, you do have to know that that means that the base is 10. It is the common log. So it is a log base 10. ln is also a log, but it is the natural log. We call it, that's why it's an N. Now, people complain, well, why isn't it in L? Well, I think they were trying to keep the capital L because it is still a log, so the N just comes after it. But this is for natural log. ln is the natural log. And it is a log with a base of E. These were two logs that got used a lot, and they were used so frequently that, yet again, mathematicians, not liking to write very much, made sure that, oh, if we use log base 10 all the time, we're not going to bother writing the 10. We're just going to say that if we just write log, it's always 10. And then E was used so often, they were like, well, we need one to stand for E too, so let's just make it ln. We'll make it even fewer letters. Instead, it's not even 3 letters, it's just 2 letters. So ln is log base E. So these are the two most commonly used logs. The problem comes is if I'm trying to type something in my calculator that has a log other than 10 and E, how can I type that into my calculator? And so what you do need to make sure that you know is you need to have some awareness of the change of base formula. Alright, so the change of base formula. The change of base formula is what is going to allow us to actually use our calculator to do all logs. So let's say that I have a log base B of A. So some number down here other than 10 and other than E, and then it's a log of some number. If I do want to type that into my calculator, I can type in common log, so log base 10 of A, and divide it by the common log, log base 10 of B. It'll also work for the natural log, so ln of A divided by ln of B. You can actually use either one of the logs, but if you break it apart, take the log of this number and divide it by the log of that number, the base, then that will give us log base B of A. So let's look at one of our examples from earlier. We figured out that log base 2 of 16 is equal to 4. Let's double check that. We know that to be true. 2 to the 4th power is equal to 16. But if I go on my calculator, if I just type log of 16, notice that's not 4. And it's because this is doing log base 10. So 10 to the 1.204119983 power is going to be equal to 16. But this isn't log base 10. So if I want to figure out what log base 2 of 16 is, I have to do log of 16 divided by log of 2. And when I do that, I do get 4. So this is the change of base formula. Take the log of this number and divide it by the log of the base. And that will allow you to use it. Now, if we did it with ln of 16 divided by ln of 2, it gives me 4 as well. So it works with both common log and natural log. But this is how we can use our calculator to help us figure out any of these. Do be aware, sometimes the decimals can be fractions, sometimes they'll be irrational and they won't be able to be written as fractions. But this is the idea for the change of base formula and what is an actual log. Things that we can do with logs, we can write them back and forth in different forms. We can write something as an exponential form, meaning that we have exponents, or we can write something in log form. We can go back and forth between the two. We can write something either way. This is important because that's a concept that we're going to use when it comes time to actually having to solve equations. So if I have 2 to the 4th power is equal to 16, this would be exponential form because I have an exponent. So 2 to the 4th power equals 16. It's an equivalency statement. It's an equation. Okay? I could write the exact same thing in log form because we know that log base 2 of 16 was equal to 4. This is the same statement, the same 3 numbers, 2, 4, and 16, but this is the way I would write it as a log, and this is the way that I would write it as an exponential. Now, when it's all numbers, it's not nearly as big a deal. Obviously, it's much more useful if we are talking about something with variables. So if I had something like log base 5 of x is equal to 2, that's the log form because it has a log in it. But I can rewrite the log as an exponential. Things that you always want to remember when you are rewriting. This is the base, this is the exponent, and this is what it's equal to. So that means 5 to the second power is equal to x. So I could rewrite this as 5 to the second power is equal to x. Well, you can see how that would be useful, because now we know that x is equal to 25. So I took this log and I rewrote it as an exponential. You can also do something similar the other direction. If I have that 6 to the x power is equal to 48, this would be the exponential form. So things that I know, 6 is the base, x is the exponent, and 48 is what it's equal to. So that means that if I'm going backwards, then I'm going to write this as a log. The base is a base is a base. So if the base is 6 here, the base is 6 here. What it's equal to goes inside of the log. So it was equal to 48, and then the exponent is what goes over here, and so that's going to be x. And so this would be something that you could type in your calculator, get a decimal for. So being able to go back and forth, take it as a log and rewrite it as an exponential, or take an exponential and rewrite it as a log. It's a matter of remembering your base is your base. It's the same in both of them. The base here is the base here. The exponent is the exponent. And the number it's equal to is still the number it is equal to. So this is how we can go back and forth between exponential form and log form. Things that you want to remember about the graph of the logarithm. It is the inverse of an exponential, which means inverses always have the same shape. They've just been turned sideways. So what you need to realize is that the log graph, the logarithm, is going to have the same 3 parts as an exponential. It's going to have an asymptote, it's going to have a pivot point, and it's going to have a curve. It's going to have those same 3 things, but it's turned sideways. So everything is turned to the side. So instead of having a horizontal asymptote, that means we are going to have a vertical asymptote. That's going to be different. The pivot point, instead of being above the asymptote, it's going to be to the right of the asymptote. And then the curve is still either going to be a growth or a decay. So it's going to go up this way or get down closer, or it's going to be a decay, and it's going to get closer on this side and then shoot out on that side. So we have growth and we have decay. As far as your equation is concerned, if we have y is equal to log of x minus h plus k, h and k are going to kind of switch places this time. So if I have k was the asymptote last time, this time h is going to be the asymptote. K this time, instead of being the asymptote, is actually going to be the pivot point. Your base, whatever your base is here, your base is still your base, and so that's still going to tell you whether it is growth or decay. If a is bigger than 1, it's growth. If it's less than 1, it's decay. You could also multiply by a negative. Remember, multiplying by a negative outside is going to flip it up or down. That would also change it to be growth or decay. And so those are the things that you want to look at for graphing. But as far as graphing, it's going to be those same pieces. So if I look at an example problem, let's get a graph on here so we can look at it. There's our graph. Alright, so when we have our graph, and we want to graph a log, so let's look at the log y equals log base 2 of x minus 4 plus 3. Alright, so things I want to remember is it's an inverse, so everything is switched. So instead of this being my asymptote, this is going to be my asymptote. It's a vertical line, and again, inside is always opposite. That never changes for any of our functions, folks. So this isn't going to be an asymptote at -4, it's going to be an asymptote at +4. So I'm going to have an asymptote at +4. My pivot point. Now, my pivot point, unless I am multiplied by something on the inside, and you're not actually going to have any of those this unit, but if it should just be 1 to the right. It will always be 1 to the right. So what we're really looking for with the pivot point is whether or not it got shifted up or down any. So it should always be 1 to the right, but this time it did get shifted up. Adding outside is always shifting up. Subtracting outside is always shifting down. So it's going to be 1 to the right, but it is going to be up 3. So there's my pivot point. 2 is bigger than 1. So that means that it is going to be a growth kind of model. So it's going up on this side and down on that side. And so this would be my log graph. So asymptote, pivot point, curve. Do make sure that all three of those are there.